Hello everyone, in this video we will see continuation of demand paging and then we will see copy on write. So performance of demand paging will go the performance of demand paging depends on so many concepts. So the stages of demand paging for worst case is given here. So we'll see what are the steps or the stages where demand paging has to go through if it is in worst case. A trap is generated to operating system, save the user register and process and then process the state. After processing state, you have to determine that the interrupt was a page fault. Because of page fault, there is an interrupt generated. Then after an interrupt is generated, check the page reference was legal and determine the location of the page in the secondary storage disk. Once the location of the page is found in secondary storage disk, then comes the issue like reading that data, or you have to copy that data to main memory. How it will happen? First you have to again find a free frame in main memory, wait in a queue for a device until read request is served by the main memory. Then you have to wait till the disk seeks or latency time, is the copying time. Next is transferring of you are doing transferring job from the disk to the main memory, means the page is copied to the free frame in the main memory. This is complete task of reading data from the disk to main memory, that is free frame in the main memory. After this, while waiting, allocate CPU to some other user, where the CPU which was interrupted by page fault is allocated to some other user. Receive an interrupt from the disk input output subsystem. After completion of this task, then you have to save the register and process state from the user. Determine that the interrupt was from the disk. Once you determine, or once the CPU determines the interrupt is from the disk, then correct the page table and other tables to show the page is now in the memory. Means the page table has to update with the invalid bit to valid bit. The page has come to the main memory, and then you have to wait for the CPU until it is allocated to the process you were in, which you got page fault. So the process has to wait for CPU, then restore the user register, means the register has to be restored, process state has to be restored, new page table has to be created, then resume the interrupted instructions. So in the worst case, the demand paging fails for longer period of time, means because it has to perform almost 12 plus 3 steps to come back and start working. So how the continuation of this, how it is calculated. So demand paging can be significantly affected from the page fault. Because of page fault, its performance will get majorly reduced. The three major activities for this is service the interrupt, read the page and restart the process. So service the interrupt means you have to carefully know which page has to be loaded for which fault occurred. Then most of the time is lost in reading the page. Then again there is a time which is given to restart the page. So these are the major three activities, means the 12 actions is categorized into these three activities for page fault. So if page fault rate is 0, means the page fault P should be always lesser than equal to 0 or greater than equal to, means 0 should be lesser than P and P should be lesser than 1. So if P is equal to 0, then it means there is no page fault. If P equal to 1, every reference is a fault. So to find the effectiveness of, or to find the effective access time, we use a formula like 1 minus P into memory access plus P into page fault time. If it is P, then it is a page fault. If it is 1 minus P, means if there is no page fault, then find the memory access time. So memory access time plus how many page faults will give you the effective access time of demand paging. So demand paging, if we take the example to find effective access time, let's consider there is 200 memory access time for one process is 200 nanoseconds. Average page fault service time is 8 milliseconds. Then effective access time is 1 minus p, means 1 minus page faults into 200 plus p into 8 milliseconds. So it is like 200 plus p into some value, which is 7,999, 800. So if one's access out of 1000 causes a page fault, then effective access time is 8.2 microseconds. From nanoseconds it shifted to microseconds. So this is like slowing down the factor by 40 times. So the percentage or the performance degradation is greater than 10%, which is gradually reducing the effectiveness or the effective access time, so which in turn reduces the CPU utilization of that process. The process becomes very weak or very slow in terms of execution. So there is a concept called copy on write came to existence because of the performance of demand paging, where copy on write allow both parent and child process to share the same page in the memory. If either process modifies a shared page, then only then the page is copied. So if there are two processes like parent and child using same page, then it will be shared until they are both the process are modifying it. If they modified it, then a copy is given. In general, free pages are allocated from a pool or zero fill on demand pages. What is it? Like, pool should always have free frames for fast demand page execution. V-fork variant on fork system call has a parent, suspend and child using copy on write address space of a parent. Designed to have it can be designed like child can call exec function. It is very efficient. So before process 1 modifies page C, it looks like this. See here, there is a process 1 which is accessing this virtual view of process 1 and virtual view of process 2, which is accessing main memory, and page A, B, C is shared by both the process. If the process 1 or process 2 needs to change the data, if I take the example like process 1 needs to change the data or modify the data in the content page 3, then the memory unit or copy on write method will give a copy of page C, which is stored or which is copied to one more free frame and allocate back to process 1. So the page C can be edited by process 1, which will not affect to process 2. What happens if there is no free frames? Then page replacement concept comes here, where memory in the main memory there will be a page found which is no longer used. So that page will be replaced with the page which is to be copied. So algorithm will find can the page can be terminated or swapped out or replace the page. So based on that, the page will be copied, means the existing frame or the page which is existing in a new in the frame will be copied back to the main memory and made free for copy on write method. This needs a algorithm which will result in minimum number of page faults. Same page may be brought into the main memory several times. There is no limit like how many times you are copying the page to the main memory. So I hope you understood these concepts. Thank you.